All right, so this video we're going to do a few example problems for circuits. See about how to combine resistors together in series and parallel, how to calculate the total current, and analyze kind of the more basic DC type circuits. So before we do, of course, let's look at what we learned from the last lecture. First of all, Ohm's law, V equals IR, where V is voltage, I is current, and R is resistance. This is the main equation we're going to use when we analyze a circuit. Usually, you may be asked, what is the total current which will flow through this circuit? Or maybe how much current will flow through this branch? Or how much voltage is dropped by this resistor? All those questions will be answered using Ohm's law, V equals IR. Of course, along with it, we have to know, because obviously we're going to be given circuits that have multiple resistors in them. If we want to find out the total current, we need to know the total resistance, so we need to know, of course, how to combine resistors together. And for our purposes, there's going to be two different ways resistors can be combined. First is series. And so the total resistance in series will be the sum of each individual resistor that's connected in series. And of course, we saw that this is basically something like this. Given a circuit with multiple resistors, R1 and R2, these two resistors are connected in series because if I follow the path of an electron moving through this wire, that electron has to hit R1. Once it gets to R1, it continues along and then has to hit R2. And it has no choice but to hit both of those resistors. Because of that, these resistors must be in series. And thus, to add them together, you literally just add each resistance together to get a total resistance. But we also know there's another way the resistors can be combined or connected together, and that is parallel. And if you have resistors connected in parallel, 1 over the total resistance is 1 over R1 plus 1 over R2. Dot, dot, dot. And for this, you can have something like this type of look. And so I know these are in parallel because if I follow my little electron around, it gets to this point. At this point, it branches off, and that one electron can either choose to go to R1, which if it does, it gets out of R1 and then continues along the circuit happily, and thus only touches R1. Or that electron can hit R2, the bottom branch, and then from R2 continue around and go through the rest of the circuit, and thus only hit R2. And so any single electron will either hit 1 or it'll hit 2, but it's not forced to hit both. And thus, these resistors must be parallel to each other, or connected in parallel, I should say. And once I know that, then I use the parallel equation. So with this, we should be able to do a few examples. So here's an example. Let's say we have a circuit. $10 volts. All right, so here's a circuit. This circuit has a single voltage source whose voltage is 10, and there's 3 resistors. Question is, calculate the total current. All right, so, of course, I know what the equation is, V equals IR. And if I want to find the current, I just solve for I. I get I is the total voltage over the total current. So that's what I need. I need the total voltage and I need a total resistance. I'm sorry, if I said current, I need the total resistance. Do I know the voltage? Yes, of course. It's 10 volts. Do I know the total resistance? No. I've got 3 different resistors here, so I need to combine them. All right, let me combine them. How do I combine them? Are these resistors combined in series? Are they combined in parallel? Or a combination of both series and parallel? Well, let's look. A little electron coming through hits 2, keeps going, hits 5. So that tells me already 2 and 5 are series. Well, let's keep going. After 5, the electron keeps going and has to hit 3. So that tells me 5 and 3 are in series. Now here's something I want you to get in your mind, because I see this every once in a while, and of course it's natural, especially if you don't have any experience analyzing circuits. What you don't want to do is try to combine the 2 and the 3 together first. So for instance, if that 5 wasn't there, if you just put your finger over the 5, then you'd say the 2 and the 3 are in series. Because once the electron leaves the 2, it has to hit the 3. So can I combine the 2 and the 3 first and then do the 5? The answer is no. Now here, with this example, it probably doesn't matter. But there will be other more complicated circuits where if you try to go out of order, you're going to mess things up. So instead, let's go ahead and try to do this the right way. And by the right way, what I mean is, the 2 and the 5 I know are in series, the 5 and the 3 are in series, so they're all 3 in series with each other. Now, what I could do is I could say, okay, let me do R total 1 first and say 2 plus 5 is 7. And then what's left is a new circuit where I've now combined the 2 and the 5 together. So now that's one single resistor whose total resistance is 7. And then you still have the 3 sitting down here waiting for you. This is true. You can do this. And in fact, when you have very complicated circuits, this is kind of what you're going to do. You're going to combine little simple things together, little by little, which creates a new circuit, which is called equivalent circuit. Because the original circuit I've drawn, in terms of the calculations I'm going to do, in terms of how the circuit works, in terms of how the current flows, is equivalent to the gray circuit I just drew. They're the same thing. It's just that the gray one is easier because now there's only 2 resistors there instead of there being 3. And so I can analyze this guy, and I already know the 7 and the 3 are in series. And I know that, of course, if you didn't watch the last lecture video, I went through this before. Even though they're drawn parallel, that doesn't mean they're actually parallel. An electron that goes through 7 has to go through 3, so it's series. So what I can do now is take this guy and say R total 2 is the 7 plus the 3, which gives me a total of 10. That's perfectly fine. And of course, you could do the opposite. You could start with the 3 and the 5, combine them to get an 8 at the bottom, with the 2 sitting there on top, and then combine the 8 with the 2. That's also fine. However, the way I would do it is I say, since I know all 3 of these resistors are all connected in series with each other, well, let me just say R total is R1 plus R2 plus R3, all three of them. So it's 2 plus 5 plus 3, which is 10. This is also fine. This would get you into trouble if there was something else going on before. So maybe there's a parallel thing over here, in a more complicated thing. Then I cannot do the 2, the 5, and the 3 because this parallel weird thing over there is in the way. However, for what we have, it's perfectly fine adding all three of these together. I get a total resistance of 10. Good. Now, I go back to my Ohm's law. Total voltage, 10 volts. Total resistance, I just calculated it to be 10. And I get a current of 1 amp. And there we go. What's complicated about this? Do I know how to find series? Do I know how to find what's parallel? In this case, everything was series. So I use the series equation, add up all the resistors, get a total resistance. Now that I know it, I use Ohm's law, V equals IR. Calculate for I is V over R, and I plug my numbers in. Next example. How about this guy? Volts. Let's say this is 3 and this is 6. Calculate the total current. All right. New circuit, same question, V equals IR. I want to find I, so I is V over R. Do I know the total voltage? Yep, 10 volts. Do I know the total resistance? No. I've got multiple resistors, so first step, let's calculate the total resistance. All right. Well, in order to do that, I need to know if these resistors are connected in series or parallel. So, let's look. For the time being, I'm going to do this let's draw the little electron thing, but after a while, you're going to be able to just visualize it without having to see it drawn or drawing it yourself. Go ahead and draw it as often as you have to if it'll make you understand and see it more clearly. But just know that eventually I'll stop drawing this little bit just because I get lazy. So here's our little electron flowing through our circuit. It reaches this point here. At this point, it's got an option about which path it would like to take. It could take the 3 and go the 3 path, or it could take the 6 and go down the 6 path. No matter which path it takes, it does not have to go to the other path. So if I take the 3, it just hits the 3 and that's it. If I go to the 6, I just hit the 6 and that's it. Since this electron never hits both, these are in parallel. So I now know my resistors are in parallel, so I'm going to use the equation. 1 over R parallel is 1 over R1 plus 1 over R2. All right. So R1, that's 3. R2, that's 6. So now I just have to add 1/3 plus 1/6. Now look, I will say, because I see it all the time, if you want to use a calculator and get decimal, that's fine. Because I've seen people try to add fractions and they don't remember how to add fractions. Remember, in order to add fractions, you have to get a common denominator. So I can't say 1/3 plus 1/6 is 1/9 or 2/9. You have to get a common denominator. In this case, the common denominator is 6. So I get 3 over 6, which is 1/2. Now, is 1/2 the total resistance? Of course, if I'm asking you this, the answer is probably no. No, 1/2 is not the total resistance. The reason it's not is because at the beginning, all this stuff is equal to 1 divided by the total resistance. So to get the total from what I have as my answer, I need to take the reciprocal. So our parallel then is 1 over 1/2, which is 2. Never ever forget this step. It's so easy to lose points because you just forget and you move on to the next step. For parallel, when you're calculating it, 1 over r is blah, 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 blah. Once you get that answer, take the reciprocal of the answer to get the actual r. Now I have it. The answer is 2. All right? Go back to my Ohm's law. I is V over R. V for this problem was 10. R total is 2. So I get 5 amps. Nice. So we've had an example with series. We've had an example with parallel. Guess what comes next? This example combines them. Because obviously, we can have even more complicated circuits where we have some of them are connected series and then others are parallel, and then the parallels connected with the series. And so let's see how to do something like that. Here's our circuit. All right, 10 volts. Let's say 8, 6, 3. Question, calculate the total current. All right, so calculate the current. Ohm's law, V equals IR. That tells me I is V over R. So I need total V and I need total R. I've got V, that's 10. Do I have total R? Of course not. I've got multiple resistors here that I need to combine. All right, well, let's see about combining them. Are they all in series? Well, let's try to track our little electron. The electron comes in, hits the 8. Then after it hits the 8, it reaches a point of path divergence. At this point, that electron can either go to 6, where then it gets back and continues going, or it could go to the 3. And then after the 3, it goes back and keeps on going. So this is weird because I can look at the electron and say, okay, from the 8, it will definitely hit the 6, or it will definitely hit the 3. So this electron is going to hit 2 things for sure. The problem is I don't know which 2. It'll hit the 8, but that one electron will either hit 8th and 6, or it'll hit 8th and 3. So I know it's kind of a series because it's going to hit 2 things, and if it hits 2 things, those things are in series. But also it's kind of parallel because there's an option about the 6 or the 3. So what do I do? Here's the trick. Forget about the 8 for a second. Let's look at the 6 and the 3 first. We'll look at these guys first. I know that part is definitely parallel because that's where the optional path thing happens. Once the electron gets to this part of my circuit, it could either do 6 or 3. So I know 6 and 3 are parallel. So let me do them first. 1 over R parallel is 1 over 6 plus 1 over 3. That gives me 3 over 6, which is 1/2. Okay. Of course, that tells me R parallel is 2. Now, how does this help? Well, if you remember, I talked about equivalent circuits before. I forget if it was this video or the previous video. But I said something about you can combine them and create these equivalent circuits. That's what we're going to do here. Instead of looking at the very complicated original circuit, I'm going to create a brand new circuit, which is much easier, and I'm going to use the information I just discovered. And that information says this yellow part of my circuit, I could replace all of that stuff with one single resistor whose resistance is 2 that I just calculated. So let me do that. Here's the new circuit. The 8 is still there. I'm not messing with him. The 10 is still there. But now, instead of this yellow circled bit of 6 and 3, I'm going to have a single resistor, and that resistance is going to be 2. This 2 that I calculated. And now this circuit is much easier to look at. I know directly what I have to do. The 8 and the 2 are series now. So I can combine the 8 and the 2 in series together and get our series is 8 plus 2, which is 10. And now I know the total resistance, because if I make one more little equivalent circuit, I just combine the 8 and the 2 together to get 10. So now what do I have? A single resistor whose resistance is 10. So I went from this guy to this guy, and then from him, I went to him. And now I have the easiest circuit of all, one voltage source with one total resistor, and now I can calculate my I. I is V over R, V was 10, my total R I just calculated is 10, so the answer is 1. And now you see how to work with a circuit whose resistors are a combination of series and parallel. Break it into pieces. Each piece you know how to do, work with him by himself. Then make a new circuit, an equivalent circuit, where you've combined those things together and create one resistor out of it. And now look at the new circuit. And then you combine what you can with him and keep going down and down and down until you're left with one last little bitty circuit that only has one resistor in it. Once you've done that, you now know the total resistance and the total voltage. All right, so I hope that's clear, because what I see a lot of times is some people will try to combine the 8 and the 6 because they say, well, look, the 8, the resistor then hits the 6, so 8 and 6 are in series. Well, no, they're not in series, because as soon as that electron hits the path difference, where it could either go to 6 or 3, you know an electron that hits 8 doesn't necessarily have to hit the 6, it could go to the 3. So you can't say 8 and 6 are in series, and you also can't say 8 and 3 are in series. But what you can say is that this combination of 6 and 3 that's parallel, whatever that thing is, that's what's in series with the 8. So you get the parallel thing, you find out that's equal to 2, and now you just pretend like it's a single resistor whose resistance is 2. And now you know how to do series. This is how you should be thinking about when you see more and more complicated circuits. This is how you should think about going about solving them. All right, here's another example. All right, here's a new circuit. Same question, calculate the current. So obviously I want to use Ohm's law. V equals IR. I want I, so I is V over R. And so, yet again, I'm down to, do I have the total voltage? I do, it's 10. Do I have the total resistance? I do not, because I have a whole set of resistors here. So, first step, combine all the resistors together to get a total resistance. Okay, not a big deal. How do I combine them? Are they series or are they parallel? Ooh, well, this is kind of complicated looking. What can I see? What can I see? Well, I have a bunch of different ways of analyzing this because when I'm looking at the circuit, I'm really killing myself to try to ask, how should I tell you to look at it? Because I'm seeing a whole bunch of things at the same time. And there's no right way to go about doing this. One thing I see, 4 and 2, look at 4 and 2. They look series to me. So I already have in my mind 4 and 2 are definitely in series. What else do I see? Well, I see this 3 and this branch that has 4 and 2. That looks like a parallel thing to me. And old 8 sitting down there by himself, he's just by himself. Forget about him. Another way of looking at it is this. Take our little electron. Here's our electron coming in. He gets to this point. At this point, he could either go to 3 or he could go down this path. So I know these two paths, the 4-2 path and the 3, that's parallel stuff. But is the 3 parallel to the 4? So, for instance, can I do 1 over r is 1 over 4 plus 1 over 3? Is that correct? Well, not really, because the 3 is not just parallel to 4, the 2 is there as well. Okay, well, does this make it better? Is the 3 parallel to the 4 and the 2? Well, yeah, the 3 is parallel to the 4 and the 2, but a better question is the 4 parallel to the 2? Because that's what you're saying if you were to write this equation right here. In order for you to write 1 over 4 plus 1 over 3 plus 1 over 2, that means you've got 3 different resistors, and those 3 resistors are all parallel to each other. What would that look like? Well, it could look like this. Four, 3, 2. That is 3 of them parallel to each other because our little electron could go to the 4, it could go to the 3, or it could go to the 2. It's got its choice. And it could go to any one of 3 paths. But is that true for this circuit? My green electron sitting there, it could go to the 3, or it could go to the 4. But it cannot go to the 2 without going through the 4 first. In order for the electron to get to the 2, it must first go to the 4. So that means 4 and 2 are not parallel. For them to be parallel, then the electron can choose to either go to 4 or go to 2, but not both. And obviously for ours, it can't do that. It has to go to both. So I know this can't be right. I cannot write 1 over 4 plus 1 over 3 plus 1 over 2 or anything like that. So what that tells me is the 3 sitting there in parallel with something, let me leave them alone for now. Let me work on what's circled in gray first. What's in gray, I know without a doubt 4 and 2 are series. So let me do them. Our series is 4 plus 2, which is 6. I've now combined what's circled in gray to be one resistor whose total resistance is 6. Now, let me redraw the circuit to the equivalent circuit. So, my left path is now a single resistor whose resistance is 6. The right path is still the 3. He didn't get touched. And then down here at the bottom, this poor little 8 guy is still being ignored. Okay, so we went from this circuit, calculated 4 and 2 in series, and created that circuit out of it. Now what can we do? Well, now I can look at the 6 and the 3 are parallel. And we've seen this before. Again, the 8 sitting out there by himself, forget about him. 6 and 3, that looks parallel to me because, again, here's a point where the electron could either go to the 6 or it could go to the 3. So I'm going to say 1 over r parallel is 1 over 6 plus 1 over 3. That gives me 1/2. Thus, r parallel must be 2. So now what do we have? Now what I've done is I've combined that parallel set of 6 and 3 to create a single resistor whose resistance is 2. Now I'm going to draw the equivalent circuit. So the 6 and the 3 are now one thing, and that one thing has a resistance of 2, and the 8 is still sitting down here. So we went from this circuit, did our parallel stuff, and created that circuit out of it. Now what? Well, it looks to me, if I were to follow the electron hits the 2, comes out of the 2, and must hit the 8. So it must be 2 and 8 are series. So now I'm going to take 2 and 8 in series and get a total resistance of 10 out of it. So I've now combined them to create one final last total resistor whose total resistance is 10, and I now have the total resistance of the circuit. In fact, if I were to draw the circuit, there it is. Total voltage is 10, total resistance, I combined the 2 and the 8 together to create a 10. And so you see, just one resistor sitting there left. So this circuit created that circuit. Now I'm done. Go back to Ohm's law. V over R, total voltage of 10 volts, total resistance I just calculated to be 10, and this circuit gives me a total current of 1 amp. And there you go. So again, we start with what looks like a fairly complicated circuit. A whole bunch of resistors sitting there. Some are series, some are parallel, some are series within parallel, all sorts of stuff. How can I go about solving it? Do one step at a time. Look at the circuit. Is there anything that stands out obvious? This is definitely series, or this is definitely parallel. For this, I know that 3 is parallel to something, but I can't tell you what that something is yet. I know the 8 will eventually be in series with something, but I don't know what that is yet. However, the 4 and 2, they're series and there's nothing in their way. So combine the 4 and 2 in series first. Redraw your circuit. Now I have a new circuit, and now I could see, aha, that 3 that I knew was parallel, I now see what he's in parallel with. What he's in parallel with is a 6. So you combine them together, and you get a new circuit. Now, that 6 and 3 that were in parallel have now created a 2, and now we see 2 and 8 are in series with each other. That gives us the final total resistance of the circuit. Now that I've whittled it down to that, I can now use Ohm's law to get what I need. Every single circuit that we do in this class will be done like this. There are obviously, when you get into higher level classes, more complicated electronics. This won't always work, and there are much more fancy techniques out there which will have to be used. But for our purposes, for what we're doing, at least for now, this is what you need to be able to do. Given a circuit, can you figure out which resistors are series and parallel? Combine them all down together to get a total resistance, and then use Ohm's law to calculate whatever it is you need to calculate. And the best way to get good at this is to practice as many different circuits as you can find. Because whether this 8 was on the bottom there, or if I drew it up here on top here, it's the same circuit. Or if the 3 was on this branch and the 4 and the 2 were on that branch, that's the same circuit. It looks different, but it's the same thing. So what you're going to find is there's thousands and thousands of ways of drawing circuits. But if you do a few, if you practice 10 or 20, then likely you would have seen the majority of ways of doing circuits. And even if you find a circuit on a test that you haven't done yet, it'll be similar to something you have done. And so you know how to go about tackling it. But at the end of the day, all you need is this, V equals IR, how to combine in series, and how to combine in parallel. And then, of course, how to be able to tell what's series and what's parallel. With that power, all of these circuits will be easy for you. So look out for the practice problems and the homework problems on Canvas. Practice as many as you can. And until next time.